Hello everyone. In this recording, we try to convert this pseudocode, which is for the next feat packing rule, to a Python code, and then try to solve this example that you saw in the lectures using the Python code. So the first thing that we need to do is to just copy paste this pseudocode into the chat and then ask it to convert it to a Python code. So one thing that I just added, so we don't want any functions, we don't need to do the comprehension, and also this is the thing that if you look at the code, that the pseudocode that you have here, we'll start from k from 1 to n, and so because it's going to make some confusion down the road, I just want to add the chat to just start indexing from 0, which is what is conventional in Python. So let's see what will be the output. So one thing that you can see here is that let's start indexing from 0 here in the loop, what you are looking for. But the other thing is that this is also this bin assignments, which starts from -1 instead of having zeros. And also, if you can see in the pie, which is the list of the items or the permutation of the items, so it starts also from 0. So you can change it manually, or you can also ask chat to tell it to that the item list should also start from 1. So this is the thing, because yeah, this is another sort of confusion. So yeah, it makes it worse. So let me do something. Okay, let's do this manually. We go to the Colab and copy paste the code here. So let's change those things that we want ourselves. So first of all, we don't want the item to have 0. So we have 1, 2, 3. I make this 4. And then we have the list of the weight. We have the capacity. This is not important. So the bin assignment could start from anything, but because -1 doesn't make sense, let's make it equal to 0. Or it also couldn't be just number. You can also have a string here, but let's make it 0. And so the first bin is also not 0, it should be 1, and therefore we don't need. So here is the bin used. So let me go through the code line by line, so we will see what we also need to change here. So these are the problem information, or the input data. So we have the permutation pi, and we have the list of the weights, and also the bin capacity, which is equal to 10, and n is the length of the pi, which is the number of items that we have. So this is the output, the bin assignment. Finally, we are looking for this list to see which item assigned to which bean. So the first bean is the bean number 1, or bean that is labeled by 1, and the remaining capacity equals to C, which at the beginning is 10. Okay, so then we are looking for each item. So for k in range of 0 to n, so we know that we can just get rid of 0. This is the confusion that your chat made, so we don't need 0 here. So for k in range of n, so at the beginning k is equal to 0, we are looking for pi 0. Pi 0 is item number 2. So pi 0 and I is going to be equal to 2. So k is 0, pi 0 is item number 2, and then I is 2. Okay, and then we are looking for the W2. Okay, here's the thing. W starts, the indexing for W starts from 0, which is in Python. So first 0, 1, and 2. So, but we don't want to look at the third item in our list. We want to look at the second item in our list, because we are looking at item number 2, so we are looking for 7, not 3 here. So the modification that we need to this line of code is to, because it's used, I can do something here, and yes. So let's define index and name index. It's I minus 1. So it can define a new variable, index, or I can just get rid of this one. So whatever the pik is. So what is the pik at the beginning? K was 0, so pik is, so pi 0 is 4. Sorry, pi 0 is 2, and I is equal to 2. So then I need to reduce this one by 1, because indexing starts from 0 in Python. So when I have this one, we saw previously that if I keep this line of code, it's going to look actually for item 3 in the list. So I need to get 1 from this one, because indexing in Python starts from 0 instead of 1. So I reduce this value by 1, and then we have the rest of the code. So when I have this one, so let me start from the beginning. So k is equal to 0, pi 0 is 2, 2 minus 1 is 1, therefore I is 1. Now we are looking for W1. What is W1? This is W0, this is W1, which is actually corresponding to item 2. So W1, is it, which is 7, is it less than or equal to 10? The answer is yes. So we have the bean assignment. So the bean assignment for I, which is 1, is going to be B, which is 1, which means the I item in our list, which is the second one corresponding to item number 2, is going to assign to bean number 1. Okay, so the only confusion here is because we start from 1 and the indexing in Python starts from 0. Okay, so here's the case. We have the assignment here, then we update the remaining capacity, which is 10 minus 7, which is 3 here, and then it is, if we don't have any capacity, so this is the time that we are opening the next bean. So we add bean by 1, we updated the bean label here, and we set the remaining capacity to be the capital C again. And here we go. The only thing that we need to change is this one, the bean used, because I changed the B from 0 to 1 here. I don't need to add it by 1 anymore here, because whatever the b is actually is equal to the number of bins that we already opened. So okay, so this is the code that we have in a Python. To make sure that the output of this code is correct, we go back to our lecture, and we try to solve this instance that we had using the Python. So let me update the code that we have. So let me check it one more time. So the capacity is 10, the pi is 253,641. 253,641. This is what we have, and yeah. So here is the thing. So everything seems okay here. Let me run this code to see what is the output. So the output is we used 5 bins, and this is the bin assignment 5 1 3 4 2 3. So let's go back to the lecture here and see what was the final solution of that one. So here is the final one. So this is 513423, and we used 5 bins. So it seems that the code that we have here is fine, and the output of for this instance was the same as what we had in the class, and we also followed the logic. This is exactly based on what we had in the pseudocode. So in the next step, after having the implementation, we try to do the correctness of the entire code, and finally we will see what try to solve some larger instances and exercises using this line of code. So see you in the next recording.